Hello, my name is Rene Freingruber. I'm a security consultant in Austria at SecConsult, and today I want to tell you something about how you can compromise a company via their firewall. So in this case, we are speaking about carrier control. So you see here, this is carrier control. It's a hardware appliance which you can buy. It's for small and medium-sized businesses. It has functionality like firewall, router, EPS system, antivirus, and VPN gateway. And all started when Rashid, our colleague, came to me. He's also an employee at SecConsult since some month. And he said, yeah, 1 year ago, when I was not at SecConsult, I found some vulnerabilities in it. So like SQL injections, cross-site scripting, remote code execution, and all that kind of stuff. And they really horribly fixed this kind of vulnerabilities. So for example, the remote code execution vulnerability, you need to exploit this one here, cross-site scripting. So Carrier in this case just fixed the cross-site scripting, but not the remote code executions. So it just come to me and say, yeah, let's have a look at this again, and let's hunt again for some cross-site scripting vulnerabilities. So in this case, we just identified 2 more cross-site scriptings. We reported it again. They just fixed again just the cross-site scripting, but not the remote code execution. So then we identified 1 more cross-site scripting vulnerability, and this is still unfixed, so we can still spawn reverse root shells on this firewall. But in this case, I want to speak about another attack vector. Basically, it works by forcing a victim from the internal network to visit my website. So if he goes to my website, I return some malicious HTML, JavaScript code, which will send my attack payload to the internal system. So it's like a cross-site request forgery attack. So in this case, we have to bypass the cross-site request forgery protections, and Carrier really horribly fails here with this protection. So you can have here a quick look at it. If you can find the vulnerability here. I can give you a quick hint. The problem is that this is PHP code and not JavaScript code, because what they are trying here is they try to get here the get or the post parameter, but in JavaScript this is a logical OR. That means the posted hash will be 0 or 1, and then they make a loose comparison. That means they are comparing the number 1 or 0 with a string. The string will be converted to the number 1. That means the check is always bypassed. The problem is they have 2 scripts, 2 PHP scripts which contain nearly all vulnerabilities, and this is the first script with this bypass, and the second script has a different CSRF bypass. So in this case, they changed. If you go back here, you see that they're using here an OR instruction. So posted hash is empty or the condition, and here they're using an AND. That means you always bypass this check if the hash is not empty. So you can again bypass this check and exploit everything from the internet. And it's really strange because these 2 files contain many, many different vulnerabilities like remote code execution, the possibility to make heap spraying, cross-site scripting. They also have another script which includes a address-based layered randomization bypass, which just leaks in the PHP scripts heap pointers and stack pointers. And both files are just not referenced by any other file or any other script on the system, and just make the whole attack working. So don't really know why they are having these 2 scripts there. Another thing is that they are using PHP, which is 5 years old, so it's PHP 5.2.13. And so we just go to Google and searched for some public known vulnerabilities in it, and we just identified that unserialize has a public known memory corruption. So in this case, this is a type confusion attack. So we're mixing up objects with double values, and this leads to a use of the free condition because we can free the object but still have a reference on it. Then we can again gain code execution with this here. And we wrote an exploit for this. Which works from the internet to spawn a reverse shell, which bypasses address-based randomization and data execution prevention. You will see this later in the demonstration. Unfortunately, I don't really have enough time to speak about this vulnerability here, but if you're interested, just come to me after this talk and I can explain you how this vulnerability is working. I can very, very quickly go over it if I have 5 minutes more. You see here a double value, and this double value has the same hash as this object here, the STD class object. That means this double value here will free this STD object from memory, But we are using here a reference to it, and that means we can just control the memory in between. And what I'm doing here is the orange part here is the new memory which I allocate over the freed stuff. And I'm saying here I have a string pointer, and you see here that I'm leaking the magic value at this start address here. So I can read any memory, but I can also get full code execution with this vulnerability. And yeah, the vendor just responded to us, okay, many of the vulnerabilities will be fixed, but for example, web server running as root is not a vulnerability, they will not fix this. And also the other remote code execution which was not fixed, they just will not fix this because it's not a vulnerability for them. And the second remote code execution, where they're using a 5-year-old PHP binary, they just fixed it by removing all unserialized codes, which is really bad because the 5-year-old PHP binary has many other vulnerabilities in it. So you can just take another PHP function with a public known vulnerability and write again an exploit for it. So it's just an example, and this really shows that they are not fixing the problem at its root, they're just superficially fixing the problems, which is really bad. And I will show you now the demonstration video. And there you also see why it's important for administrators that they also configure strong credentials for internal systems, because in the demo, I'm brute forcing the internal login via this cross-site request forgery, even if no port is open. So let me just open. So you see here I have downloaded carrier control for VirtualBox. You can just download the demonstration version on the website. So it's running in the internal network. Then I go to my attacker website. The typical website would not look like this. It would look like a normal website, so the victim would not notice that an attack is ongoing. In this case, I just added here the bug output so that you really see what is happening. So I'm now starting to identify at which IP address in the internal network carrier control is running, because I want to send requests to it, so I have to know the internal IP address. I do this by loading images from different IP addresses. For example, from IP1, I try to load the carrier control logo from the fixed path. From IP2 and so on. And then I can, inside JavaScript, I can register a callback, so on error or on load will be called. Using this method, I can identify if carrier control is running or not. So I then obtain the internal IP address of it. So you see here, all these images which could not be loaded are IP addresses where carrier control is not running, but the image where carrier control is shown is the valid IP address. So the next step is I check if I'm currently logged in, because I'm making a cross-site request forgery attack. So you see here in the below part, here, this here is the user image. So I'm trying to load the user image, which is not loaded if he's not logged in, but if he's logged in, the image will be loaded, so it's the same trick again. And if he's not logged in, I'm sending just via cross-site request forgery login requests and to obtain the credentials of the internal system. So even if no port is open from the internet, because I'm forcing the victim browser to send the requests for me. So I then obtained valid credentials. The next step is to make heap spraying. So I'm sending again via cross-site request forgery many heap spraying payloads. So you see this here. And after that, I'm just calling unserialize, and it should spawn me a reverse root shell on it. So this takes a little bit. So now I'm setting unserialized data and calling unserialize on it, and then you see a reverse shell will be spawned with root privileges on the firewall or VPN gateway. So from there you can then further attack the internal system or the internal network of the company. Thank you.